The next unit in Unit 2 polynomials, we're going to be going over the fifth factoring technique, which is factoring using differences of squares. So hopefully, when you read this title, difference means subtraction and squares means perfect squares. So when you're doing this, you're looking for three things. There must be two terms. So all these problems we're going to be looking at has two terms. That's the first thing. Second thing, there must be a subtraction sign. And then the third thing is both terms must be perfect squares. Both terms must be perfect squares. All right, I've got about 7 problems to go over. The directions will say factor. I think I'm going to change that, please. So number 1, I've got x to the 4th minus 36. So all 3 of these have to apply for each problem. So are there two terms? Yes. Is there a subtraction sign? Yes. Are both terms perfect squares? Yeah. Well, what times itself is going to give you x to the 4th? Well, that would be x squared and x squared. What number times itself will give you 36? Well, that would be 6 times 6. But because that 36 is negative, one of them has to be a negative. It doesn't matter if it's the first one or the second one. So 1x squared is going to go with 1 6. The other x squared is going to go with the minus 6. And I could have written that x squared minus 6, x squared plus 6. It doesn't matter. Number 2. I've got 100 minus a to the 6th. All right, let's go through these questions. Number 1, are there two terms? Yes. Is there a subtraction sign? Yes. Are they both perfect squares? Well, what number times itself is going to give us 100? 10 times 10. What times itself is going to give us a to the 6th? So it's a cubed. I just get into the habit of putting the second term as the negative. You could put it the first term, it doesn't matter. So I've got 10 plus a cubed, 10 minus a cubed. Whatever's the minus, that's where one of them is going to be negative. It's not always going to be the number. It depends on what this problem looks like. Number 3, I've got negative 49b squared plus 81a to the 4th. All right, let's go through the questions. Are there two terms? Yes. Is there a subtraction sign? I see an addition sign. So when you go to the middle and there's an addition sign, you go to the first term. Since there's a minus there, all I'm going to do is flip this around. If there wasn't a minus here and there wasn't a minus here, then I would be saying prime. There has to be a subtraction sign. So I'm just going to flip these around. Now I can do differences of squares. I've got 9a squared, 7b, and negative 7b. 9 times 9 is 81. A squared times a squared is a to the fourth. 7 times negative 7 is negative 49. B times b is b squared. So I've got 9a squared plus 7b, 9a squared minus 7b. All right. Next one, number 4. Well, let's do y to the fourth minus 81. Y to the fourth minus 81. Let's break down that y to the fourth to y squared and y squared. And then the 81 to 9 and negative 9. So I've got y squared plus 9, y squared minus 9. So before we say we're done, this is a special problem because if I take a look, I can't do this, anything here, but I can do something here. I have two terms, I have a subtraction sign, and they're both perfect squares. So this is y, and this is 3 and negative 3. So this comes down to y squared plus 9. Then I have y plus 3, y minus 3. So it could happen where you can do differences of squares twice. You really need to check the problem. Once you think you're done, go through and check that. Let's just make sure you can read it. Number 5. I've got 5a squared minus 7b squared. First question I'm asking myself, are there two terms? Yes. Is there a subtraction sign? Yes. Are both of these perfect squares? Well, 5 and 7, they're not perfect squares. If there are no perfect squares, it cannot be factored. It's prime. You'd have to leave it like that. It cannot be factored. Number 6, I've got 3x squared minus 27y squared. So 3x squared minus 27y squared. All right. Is there a subtraction? Are there two terms? Yes. Is there a subtraction sign? Yes. Are both of those numbers perfect squares? And the answer to that is no. But I can take out a GCF. There is a GCF. It's 3. So it becomes, if I take out a 3, 3 divided by 3 it cancels. I'm left with x squared minus 27 divided by 3 is 9, and the y squared stays. From here, now I can do differences of squares. So this is x and x, 3y and negative 3y. You cannot drop that GCF. That comes down. I've got x plus 3y, x minus 3y. So I'm going to bring down that GCF. I've got x plus 3y, x minus 3y. Last one, number 7. I've got 20x squared y minus 45x to the fourth y cubed. So 20x squared y minus 45x to the fourth y cubed. Okay, there are two terms, there is subtraction sign, but 20 and 45 are not perfect squares. So the next thing I'm looking for is a GCF, which there is one. It's 5. But they also have some variables in common. They have 2 x's in common, and they've got a y in common. So really, my GCF is 5x squared y. 20 divided by 5 is 4. The x squared cancels, the y squared, the y's cancel. 45 divided by 5 is 9. 4 minus 2, that's giving us 2. 3 minus 1, that's giving us 2. This can be broken down to 2 and 2. Now I can do differences of squares. This becomes 3xy and negative 3xy. I'm going to bring down that GCF, so 5x squared y, 2 plus 3xy, 2 minus 3xy. And that's factoring using differences of squares.